All right, here we are about to finish section 5.3. This is my part 2 video, just going to wrap up a few examples, starting with something similar to our previous video. Instructions say find the 6 trig functions given that sine of theta is 4/5. That sine value is positive, but there are 2 quadrants in which sine is positive, so we need more information in order to know where to put that triangle. So they tell us quadrant 2, that's important. I don't think my drawing is to scale, unfortunately. If this is 4 and this is 5, we know that's a 3, 4, 5 triangle, and because of its placement in quadrant 2, that tells us that that has to be -3. We also know that cosine in quadrant 2 is negative, so -3/5. We know that tangent in that quadrant is also negative because that's sine divided by cosine, or you can think opposite over adjacent, -4/3. I'm going to do the evil twins now, or the reciprocal functions. Sine is paired with cosecant. Find the reciprocal, that's 5/4. Secant goes with cosine. The reciprocal of that would be -5/3. And then cotangent would be -3/4. Remember that memory trick? All students take calculus. All trig functions are positive here. Only sine is positive here. So if we go through and we check, that also would include cosecant because that's the reciprocal. Then the rest of these would be negative trig functions. So something I don't think that we talked about in our first video was the values at the corners. We did talk about it when we did our drawing of the unit circle last week. The corners, if you think about the coordinates there, the x-coordinate is 1 and the y-coordinate is 0. That means the cosine at 0 radians, or you could even think of that at 2 pi radians, is equal to +1. The sine at 360 degrees is 0. Okay, so when you find the reciprocals of those, secant of 2 pi, the reciprocal of 1 is going to be 1. But be careful, cosecant of 360 degrees, this is like 0/1. If I do the reciprocal, that's going to be undefined. So you will have some values across that are undefined, so be careful. That's going to come about with those reciprocals. My top corner are at pi/2. Think about the ordered pairs that are there. 0 for the x, that means cosine is 0, and our sine value is +1. At pi radians, my cosine value is -1, sine value is 0. And finally, at 3 pi/2, my cosine value is 0, and my sine value is -1. Didn't mention those in the previous video, and I thought that I should do that. Okay, lastly, I just have a couple application questions. I'm going to select a few of our textbook problems and do them myself. The instructions from number 89 ask us to simplify without using a calculator, and they want us to write our answer as a single fraction. So pretty complicated expression here. I am seeing 2 angles consistently identified throughout. One of them is 11 pi/4, and one of them is 5 pi/6. So I'm going to go off to the side. I think it would be important for us to figure out where is 5 pi/6. What does that look like? So we have more information there. You could also pull out your unit circle to do that, but I do think it's wise to practice figuring that out yourself. So if we were to go in the positive direction all the way over to pi, pi would be equivalent to 6 pi/6. So this means that we're not quite there. In fact, we're 1/6 of pi short. Okay, the reference angle that is created is pi/6. Pi/6 is equivalent to 30 degrees. If you look at your unit circle that you have labeled, The cosine value, that's the longer leg, would be root 3 over 2, but it is in quadrant 2, so it's negative root 3 over 2. And the sine value, sine is positive in that quadrant, would be positive 1/2. All right, let's take a look at 11, what was it? 11 pi over 4 was the other one. Okay, if I started at 0 and I went all the way around, that would be 8/4. Here would be 9/4. Here would be 10/4. Here would be 11/4. So we are located here, again in quadrant 2, and the reference angle is pi over 4, or 45 degrees. I love when they're 45, 45, 90s because that means that it's root 2 over 2 for both. However, remember that we are in quadrant 2, and in quadrant 2 our x's or our cosine values are negative and our y values are positive. Okay, so now I'm just going to plug these in. Sine of 11 pi over 4. I'm looking here. So that's my second picture that I have. The sine value would be the y value. That would be equivalent to root 2 over 2. Cosine of 5 pi over 6. I'm back to my blue sketch. Cosine would be the x value, so that would be multiplied by negative root 3 over 2. Next, cosine of 11 pi over 4. That's the x coordinate, negative root 2 over 2 from my green drawing. And I'm multiplying by sine, or the y value, from my blue drawing, positive 1/2. I'm multiplying fractions, so I'm going to multiply straight across first. That would be negative square root of 6 divided by 4. And we're adding that to negative square root of 2 divided by 4. They want a single fraction. Those are common denominators. Negative root 6 minus root 2. Those are not like radicals, so that's going to be as simple as that gets. You can leave it like that. You will see from our textbook, though, they love to factor out that negative. And they're going to write it like this, I think. Both of these are acceptable. You're going to need to know how to switch between those two, or at least recognize this second one as the same answer as the one above. Okay, I think I have one more I'd like to do with you. This is like number 99. It says find two positive values of theta between 0 and 2 pi. So the first thing I'm going to look at when I see these, it says that the cosine value is negative. So I'm going to start by narrowing down what quadrants that would apply to. Cosine is negative in quadrant 2 and also in quadrant 3. Next, I would identify what angle or what reference angle that would go with. Root 3 over 2, that would be when the x value is the longer leg of a 30, 60, 90 triangle. So if you think of that, this is pi over 6. That means that this happens at 5 pi over 6. It's 1/6 of pi short of having 6 out of 6. That reference angle is going to remain the same in the other quadrant. So another pi over 6 reference angle, but when I measure that from 0, 6 pi over 6 plus 1 more, that's going to be the other one, 7 pi over 6. Alrighty, I think that should get us through 5.3. I'll get you guys some practice problems to go with those.